Welcome to the session on differentiation, differentiating quadratics. The objectives for this session are to explore examples of differentiating quadratics. Recall that for all real values of n and for constant a, if y equals ax to the power n, then dy dx equals a times n times x to the power n minus 1. A function with more than one term can be differentiated by differentiating terms one at a time. Deriving the derivative of the quadratic. The quadratic y equals ax squared plus bx plus c, where a, b and c are real numbers, can be differentiated by differentiating one term at a time. So, differentiating ax squared gives 2ax. Differentiating bx gives bx to the power 1 minus 1, which equals bx to the power 0, which is of course equal to b. And differentiating c gives 0. Do note that we're differentiating cx to the power 0, and in fact, constant terms disappear when you differentiate. Now, if y equals ax squared plus bx plus c, where a, b and c are real, then dy dx equals the sum of these, so it equals 2ax plus b. So here's y equals ax squared plus bx plus c, and here's 2ax plus b plus 0. Now pause the video and have a go at this example. Press play when you're ready to view the solutions. Now let's solve example 1a. We are required to find the derivative of y equals x squared plus 5x. We can use our formula for the quadratic. If y equals x squared plus 5x, then dy dx equals 2x plus 5. How did we find this? Notice that in our quadratic, a equals 1 and b equals 5. We can simply plug these values in to obtain dy dx equals 2 times 1 times x plus 5. Let's now solve example 1b. This time we're required to differentiate 2x squared minus 3x minus 4. Here we have in our quadratic that a equals 1, b equals 5 and c equals minus 4. And therefore dy dx equals 4x minus 3. So we obtained the values of a, b and c from our quadratic and then plug them into our formula for dy dx, which is equal to 2ax plus b. And now for example 1c. We are required to differentiate y equals x squared plus 5x. This time we have that a equals 1, b equals 5 and c equals 0. And again, plugging in to the formula gives us dy dx equals 2x plus 5. So from here we obtained the values of a, b and c. And here we plugged into our formula for dy dx. Now let's have a go at example 2. Pause the video and have a go yourself. Press play when you're ready to view the solutions. So let's solve example 2a first. Let f of x equal 5x squared minus 6x plus 7. Find the gradient of y equals f of x at point 2, 15. So if y equals our given quadratic, then dy dx equals 10x minus 6. Here's our quadratic, and here's dy dx. So each term has been differentiated. And we've simply plugged in the values of a, b, and c into our formula. Now at 215, dy dx equals 10 times x minus 6. And here we have x equals 2. This, of course, gives us 10 times 2 minus 6, which is equal to 14. Now let's solve example 2b. Let f of x equal 5x squared minus 6x plus 7, at which point on the graph is the gradient equal to 5. So let's solve this. Now if y equals our given quadratic, then dy dx equals 10x minus 6. Here's our quadratic, and here's dy dx. Now from our question, we know that the gradient is equal to 5. So therefore, given that dy dx equals 10x minus 6, we can conclude that dy dx equals 10x minus 6 equals 5. If we rearrange this, it gives us that x equals 11 over 10, or 1.1. And then plugging this into our equation for y gives us y equals 6.45. So the gradient is equal to 5 at the point 1.1, 6.45. Now let's solve example 2c. Let f of x equal 5x squared minus 6x plus 7. Find the gradient of the curve at the point where the curve meets the line y equals 4x plus 2. At the point of intersection, we have 5x squared minus 6x plus 7 equals 4x plus 2. So rearranging gives us 5x squared minus 10x plus 5 equals 0. And then dividing by 5, and factorizing gives x minus 1 all squared equals 0. So at the point of intersection, x is equal to 1, because this is the only solution for this particular equation. Now we know that dy dx equals 10x minus 6. And therefore the gradient at this point, when x equals 1, is equal to 10x minus 6 equals 10 times 1 minus 6, which of course equals 4. This brings us to the end of this session. If you have understood its contents, you should be able to explore examples of differentiating quadratics. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.